So we're going to continue with lesson 10. We're into our second hour. We've written a couple of really simple unit tests. We've recognized that we're going to have to cast our iAction result that all our methods return as a view result, and then we can evaluate our view name. Now we're going to make one other change to our index method and write one additional test for this, just so we can see how it works. So go back to our web project, our dummies controller. Then we'll set up a variable here in our view data that we can then expose and make visible inside of our view. View data. We'll set up a message variable here. Message from the controller. So now we're going to display this variable first in our view, and then we can write a unit test to evaluate this message and make sure it equals this string. So I'll jump back to the view. And we'll put on a tag. So we're going to output our view data message variable inside of a paragraph here. And so view data is very similar to the view bag. So we're going to write one final unit test for this method, and we want to check that our variable is equal to message from the controller. So I'm going to go back to my unit test class. We'll write one more test method. Index shows view data message. So you don't have to use this test name, but I'm trying to describe not only the method, but then what happens in the method. Our arrange and act, those are going to be the same. We're instantiating our controller. We're calling the index method and casting the return type as a view result. So again, we can use R equal. So we are expecting to get message from the controller. And what we actually got back is our result object dot view data. So we're evaluating the message variable inside our view data object. Now I'll show you one other useful tool. I think it's useful. We might turn this off later, but while we're unit testing, it's useful. If I go to the test menu, if I turn on live unit testing and click start, what this will do is every time we change a controller method or write a new unit test, it will automatically run the tests. So if I save my file here, it basically checks it automatically. So I'll just run the test. So it's almost like a preview before running the test that tells you whether your test is going to pass or fail. Some people don't like this and don't want it on, but I'll show you that it's here. Okay, so now all three of our tests pass. Now I have a bit of an architecture question here. Do we need 3 unit tests? Here's our method. There's 2 things that happen in it, right? We set a variable in the view data and we load a view. So we wrote separate tests for this. Any thoughts around what if we wrote one unit test instead? Do you think it makes sense to write separate unit tests? Or to simply have one test? Developer opinion is sort of divided on this. What do you think? Okay, Megan, you said you prefer separate tests in case one fails. Okay, any other opinions? Do you agree with Megan? Do you like having different tests? Or would you rather write one test? Okay, Jacob, you agree? Chris likes one test because all the data is static. If there's a view, the view data will be there. Austin, you like it separate? Megan says, depending on how granular you want the test, one could suffice. Okay, these are all fair points. There's not an absolute right and wrong. In fact, if we look at the unit testing documentation from Microsoft, they actually have let's just go here. I used to have the link here. Okay. Let's have a look at their sample. Now this will look may look slightly different. So they kind of break this out. Thought they might have a sample for us here with multiples. I know some of the samples here, I think it's with one of the other testing frameworks. They actually write multiple assert statements in one unit test. Personally, it's more work to write multiple tests, but I prefer it. I would prefer to test every single execution path within a method, everything that could happen in its own test. Because the problem is if your test fails and the multiple things happen in the method, we don't really know which part of it failed and why. So for example, let's look at our books controller. So let's look at our details method. We're going to actually unit test this in a little bit. How many different things could happen in the details method? So when we call books details, how many different execution paths could this code take? Right, we've got 3 different possibilities. The first possibility is we've called details, but we don't pass an ID. In this case, we're returning an off found. Our second possibility is we have an ID parameter, but when we query the database using that ID parameter, again, there is no matching record. And then the final possibility is our query runs and we do actually find a matching book object. So I think to properly unit test this, we should have 3 separate tests, one for each possibility. Some developers will write, so that leads me to the practice of one assert statement per test. You will see some sample unit tests where developers might write multiple asserts. I personally don't like that practice, and I would discourage you from doing it. It's not wrong, but I don't think we get the full value from our unit tests if we do this. You'll also notice for some reason the code coloring, it doesn't update. The code coverage doesn't update, even though we've run this test again, and it says both this line and this line pass. I don't get the blue highlighting unless I run that code coverage all over again. They've never fixed this, and I don't know why. There's no ability to refresh the coverage. which I find annoying. So in the dummies controller, we're still at 100%, but now we're covering 5 of 5. So when I run it again, now both lines turn blue, telling me they're covered by unit tests. So it's not that our percentage has gone up, but we've added more code. Okay, so those were some really basic unit tests, just to get a kind of a feel for how the unit tests work, and some with our arrange, act, and assert, that we'll have to deal with the iActionResult parent class by casting it, and also that we should be explicit in our view names and our return statements. Does anybody have any questions so far before we move on to starting to unit test our books controller, which is going to be a fair bit more complex? Okay, so we're going to start on this. So we're going to be creating a new class in our test project in a minute. We'll create a new one down here. And we want to use it to unit test the methods inside of the books controller. For today, we're just going to test the index and details method. We'll write the rest of the unit tests next week. That'll be part of your in-class lab. Yes, we are going to do that, Megan. Absolutely. One of the other decorators we have here is called test initialize. So if we want to arrange things, to arrange objects or variables that are globally available to all the methods in a test class, we can run them inside a test initialize method. We're going to do that. So that's a great point, and yes, we are going to do it. Now we've got an issue here. Well, let's start setting it up first. I guess we'll let the issue arise. So in our unit test project, I'm going to right click. I'm going to add a class. I don't think there's a specific template here for the unit testing class. I'll search, but I don't think so. Okay, it does give us, if I search tests, well, this is just an SQL server unit test, so we don't want that. Okay, so I'm just going to pick a general class. I'll call it books controller tests. So it's going to be set up just as an initial test class. Just looks like this. We'll need the test class decorator. And we're going to need some references. Notice we don't have a reference to Visual Studio unit testing. So I'm going to add that reference. Let's start out by writing a similar test to make sure that the index method loads the index view. So we'll create a test method. Index loads correct view. Now, Megan, we will use that test initialize method in a minute, but it's not quite yet. Range. Assert. So we want to instantiate an instance of the books controller this time. Now we're in a new class, so again, we'll need to reference our web project controllers. So we're missing a reference here. We'll reference our last chapter.controllers. But now we've got a different issue. We didn't have this issue before. How come this generates an error? So we reference the controllers. This worked fine in the dummies controller. We just instantiated an instance called new. This works fine. What's different about the books controller? What is this kind of cryptic error telling us? There's no argument given that corresponds to the required formal parameter context of books controller. What the heck does that mean? So the same code worked in our last test class, but it's not working now. Right, thank you, Chris. If we go back to our books controller, right, we scaffolded this. When we scaffold a controller using entity framework, we get a constructor, and this is using dependency injection. Right? Our books controller, it requires an application DB context object. It needs a database connection because all of the methods here that do CRUD, they all use the database. There is no empty constructor. So you cannot instantiate an instance of the books controller if you don't pass it a database connection object. Now, this creates a little bit of an architecture problem. I mean, we could just connect to our SQL Server database here and pass that object. But if we do this, we're no longer unit testing. Right? What did we say it's called if we're testing our web application and our database talking together? That's not unit testing, that's something else. What kind of testing is it when we're testing with another component? Right, thanks, Chris. That would be integration testing. So we need some way to test the methods in our books controller without actually having to connect to our SQL Server database. So how are we going to do this? Well, what we're going to do is we're going to use an in-memory database. It's kind of like HTML5 local storage. So the database gets created in memory just inside of our class here for the purpose of running our tests. And then we can pass that in-memory database connection when we instantiate our controller. So this will allow us to invoke the controller without actually connecting to SQL Server. But there's a bit of setup that's going to be involved for us to do this. So first thing I'm going to do is I'm going to comment out this line. And I'm going to we're going to need a NuGet package for this. I'm going to click on Tools and go to Manage NuGet Packages for Solution. There are a few different tools available for creating a mock or an in-memory database. So again, go to Tools, NuGet Package Manager, Manage NuGet Packages, and then make sure you click on the Browse tab here. And we're going to search for the word in memory with no space. And that's going to bring up this package, downloaded 88 million times, the Entity Framework Core in-memory database to be used for testing purposes. Perfect, that's exactly what we want. Now there's a couple options we need to pay attention to when we install this. I'm going to click on this. And now notice we've got two projects. We haven't had to deal with this when we've installed NuGet packages before. We only need this dependency in our test project. We're not using it in the web project, so just check off your test project. The other thing is this latest stable version 6, this is for .NET Core 6. I'm going to choose the latest version for .NET 5. So I'm going to change that version from 6.0.0 to any version that starts with a 5. Okay, so I'm installing it in the test project. I'm making sure I'm installing version 5 something. and then I'll click install. Okay, so install that package. Oh, I put my method outside of my class, which makes no sense. Okay, so now our method lives inside the class. So before we call our arrange, we need to set up a database in memory. And then when we call new, we're going to have to pass that database object here. So inside our class, sorry, this would be private, application DB context, right? So we're declaring an instance of our database connection. This is our in-memory DB connection. We can also declare, and Megan, this comes back to your question, an instance of our controller at the class level. So we don't have to keep creating it over and over again inside of every method. We can now create this test initialize method that's going to run before each unit test automatically. I guess we should fix up our missing reference here. It doesn't recognize application DB context, but we can reference our data folder, our data namespace. So I'll create a method also called test initialize. So this runs automatically before each test in this class. Maybe I'll just move this comment up here. So we want to set up our in-memory DB. We're going to use this class. We'll need to make a reference in order for it to work. And we'll pass in our database object. We're going to set up a couple of options here. In our startup file of our web project, we have an option that was set there that said use SQL Server. We're not using SQL Server. We're going to use an in-memory database. And we have to provide it a unique name each time, so there's no conflict. So to do this, we'll just use a GUID. We'll randomly generate a name for our in-memory database. And then we can instantiate our database. So this creates a new database in memory with a unique name. In order to get this to work, we'll need to make an entity framework reference here to the entity framework core. So this code won't build unless we add this reference to entity framework core. So this creates a database with a unique name. Now we can instantiate our controller in our test initialize. So now we can call new and pass in our context. So now we can call the constructor and we have a database object we can provide. So this setup, so it's going to crash here because we're not providing that dependency of a database object. So we're going to do it here, and then we no longer need this line. Pardon me. So our controller will get created before every test automatically in the initialize method. So we'll comment out the arrange. We'll just try the act and assert here. So now we can call index. Again, just like in our dummies test. This is a little bit different. Similar. Again, we'll call view results. We want to cast it as a view result. And again, we're going to need to reference, just like we did in the dummies controller test, we need to make a reference to .NET Core MVC. Also, our behavior here is a little different. We didn't get this error before. Cannot convert type system.threading.tasks task iAction result to a view result. How come we got this? It worked fine over here. Right, this is the exact same line of code. If I copy it, they're identical. So what is this error telling us? Why do you suppose it worked with our previous unit test, but it's not working with this one? Maybe we should take a look at the two index methods, one in the dummies controller and one in the books controller. So here's the dummies controller. Here's our method. Here's the books controller that we scaffolded. Here's our index method. So what do you notice that's different about those method definitions? This is the clue as to why we're getting an error. So again, here's the dummies index. And here's the one we scaffolded. They're similar, but they're not exactly the same, are they? Good guess, Megan. No, it's actually not about the database. And I'll copy the method header. It has to do with the method header. Let's look at them together. So how are line 28 and 29 different? So line 28 was our own code. Line 29 was the scaffolded code. the return types are similar, but they're not identical. So our dummies controller, that's right. Here we're just returning a generic iAction result interface when we wrote our own code. In the scaffolded code, it's not actually an array, but it's an asynchronous task. So this is just a sort of generic response that runs asynchronously that's of type iAction result. So our dummies controller was a synchronous call. The scaffold calls are asynchronous, and they return a task object that are typed. So how we handle these responses is a little bit different. So what we need to do here is see if we can do it this way. Yeah, okay. If we use the result property, this gets the result of our asynchronous task. So because this method returns an asynchronous task object, we need to evaluate the result property instead. Now we should be able to run the same assert we did before. So we're expecting a view called index, and we will compare it to the result.viewName. So we can say, so this is now done in test. So now I want to run my test. So go back to my test explorer, then run all my tests. And something else a little weird happens. We see our dummies controller test, but we don't even see the books controller test. Never mind, it failed. Never actually ran, right? There's no indication of pass or fail. This method doesn't show. We're missing one thing on line 15. So it's like these tests totally get ignored. Right? Our test explorer doesn't even see them. Any suggestions on line 15? So here's our dummy controller test declaration. Those tests all run. Now when I try to run the test in my books, it doesn't run. What am we missing here? That those tests aren't getting recognized. Thank you, Jacob. So there's a little bit of a got you for when you create a test class. By default, it won't be public. Must add public scope tests to be visible. Okay. So now I'm going to try to run my tests again. So now it shows our books controller test, one unread test. So it can see it, but it failed. Now we've seen this problem before. It expected a string of index, but it got back null. So our test is actually correct. What should we do to fix this? We had to do it in the dummies controller as well. So when it's evaluating the name of our view, here, this second parameter is showing as null. So we should modify something in our books controller in the index method. We want to change something in our index in our return statement. What should we do here? So that we can confirm we're getting back the right view. We did it here. So our return statement is sending back a list of data. We'll deal with that after. Thanks, Chris. So before the data, we're going to use this fourth overload, which is the name of the view first, and then our query results second. So I'm going to save that. I can try and run my test right from here. And now my test passes. Our test passes because we're now specifying the name of the actual view. So we're going to add that string parameter before our asynchronous call to fetch our list of data. I'll go and look at the code coverage again. And now our controller is, all right, we're up to 3.39% coverage. So in our index method, well, it says we're 100% covered. We're probably not. We're not in my mind, because we will need another test here. We'll want to make sure that we actually get back the data we're expecting as well. So our first test is good. We're checking that we get the right view. But we also should be checking that the index displays the data that we want to see here. So we'll need to use our in-memory database a bit more. We're going to mock up. We're going to create the database, but before we pass the database to the controller, in here, we are going to create mock data for testing. So then in our setup, we'll create a few records, and then we can work with the data, both in index, and then later on, we're going to write unit tests for details, where we have that in-memory data set we can play with. Okay, so we're going to do 4 more unit tests today. We're going to take a break. When we come back, we're going to mock up the data. First, we'll test the data we get here in our index, and then we want to test the 3 different conditions inside of the details method, as well possibly that the details view also loads. Okay, so we'll do 4 or 5 more tests before we finish for today. Okay, I'm going to pause the recording. I will upload to Git, and we'll come back at 3.